Alright, in this lesson we're going to be able to model and solve problems using absolute value. And as always, Cornell notes, you want to write down the keywords and the concepts and organize those in a manner that you'll be able to use them and study with it later. One of the vocabulary words for this unit is absolute value, and so let's go ahead and define that. And absolute value is basically the distance from 0 on a number line. The distance from 0 on a number line. Or it doesn't necessarily have to be on a number line, but distance from 0. So, for example, let's just draw this number line out here. Okay, so pretty simple. If I'm at 4, I am how many units away from 0? Well, obviously I'm 4 units away. Maybe, I don't think it's too terribly difficult, but let's look at, how about if we're at -5? Okay, so if we're at -5, most of us can see that we are 5 units away from 0. And so when we're getting absolute value, we always give the absolute value in positive terms. So the symbol for absolute value is, it's like parentheses, but it's 2 straight lines instead of curved lines. So it looks something like this. This would be the absolute value of -5 equals 5. And the absolute value of 4 is not -4. It's positive, but it's 4. So no matter what, when you take the absolute value of something, it becomes a positive number. The absolute value of -11 is 11. The absolute value of 7 is 7. You want to make sure that when you're taking the positive number, you're taking the positive value inside the absolute value sign, because sometimes somebody, they'll have a question and it will look something like this: negative absolute value of -7. Well, you treat absolute value kind of like you would parentheses, where you solve inside the absolute value, you get the absolute value of -7 is 7, and then now since you have this negative out on the outside, that gets attached last. So, and this solution would be -7. Anyway, because again, the negative inside became positive with the absolute value, but then you had the negative outside. So I think most of us can see that and understand that. Now, what kind of problems would you use absolute value for? Well, there's a few applications that I can think of. For one, a lot of things that we can see in our natural environment that involves negative values. Sometimes you want to use the absolute value to find a change. So for example, if you woke up in the morning and it was -5 degrees out, we'll just say it's Celsius if you want to use that. And then by the middle of the day, let's say it rose to 10 degrees Celsius. Well, how much did it go up? Did it go up only by 5 degrees? No, we can see, and there's many different ways to do this, but if we were to just draw a thermometer and have this be 0, and this would be -5, and up here would be 10, we can see that the absolute value between 0 and -5 is 5, and the absolute value from 0 to 10 is 10, and so the total change in temperature is 15 degrees. Very similar to adding and subtracting integers, right? Okay, let's see, what would be another example? I don't know if you ever are hiking, or maybe there's a change in elevation. Maybe you've ever seen the the elevation in airplanes and stuff like that. But let's say you're hiking, and so let's say you wanted to see. Let's say you actually even had the opportunity to be in a center, lowland, below sea level, and so you were maybe, well, what do you want to say, negative, or let's just say 70 feet below sea level. Okay, you're 70 feet below sea level, and you climb to a mountain of 1,100 feet. No, that would probably be too much. Let's do 800 feet. That would be quite the trek in one day, huh? So again, you can see, similar to that problem, you'd have the 800 above sea level, 70 below sea level. You take the absolute value of that. Even if you were to make that 70 a below sea level and designate it with a negative, I think we can see that's 870 feet change in elevation. Now, here's one more last kind of tricky one for you, maybe. Let's say you leave your house. Okay, that's your house. And you're going to school. I don't know how you draw a school, but that's a clock. Let's say you leave your house and you go to school. And let's say the distance between your house and school is, let's say, 15 miles. Okay? And again, these are, I'm giving you a verbal word problem, but obviously I'm demonstrating a strategy to solve these in writing these scenario out for you. So it's a good thing to kind of note. Let's say you left your house, you're maybe, let's say, riding a bike to school, because I think 15 miles is a bit much to walk. You're riding your bike to school. 8 miles into your bike ride, you drop your wallet. You don't know where it was. You didn't know it was at 8 miles at the time. But 8 miles into your bike ride, you drop your wallet. You get to school. You realize you don't have it, and you have to go back. You go back. You find your wallet at the 8-mile mark from your house. You go back to school, and you get to school and you say, "I'm beat. I must have biked over 25 miles today." And your friend says, "What are you talking about? You only live 15 miles away." And so you want to figure out, be able to tell them actually how far you actually biked. So again, we can see that even though the distance from your house to the school is 15 miles, all that back and forth you did is at added distance. We think of distance always in a absolute value, positive. No matter if you're going or coming, you're traveling. If you're in a car, you're using gas. If you're in a bike, you're using energy. So we can model this. Let's see, in the 8-mile mark. Let's see, this is 8 miles, right? So you actually had a distance of 15 miles when you originally went to school, and then you went back. How many did you go back? If you're 8 miles from your house, you went back 7 miles, right? And so even though you're going back, and then you're going to come back again another 7 miles, all of that counts as energy that you've used up. And so actually, let's see, if we get 15 plus 7 plus 7, I think that will be 29 total miles that you ended up traveling. And so maybe you can see, I hope, that even though you know you're still only 15 miles away, you actually ended up traveling back and forth much more than that. And that's a kind of problem that would use, you're using the absolute value, the distance, back and forth to be able to kind of get a mental picture in your head of what's going on. So that's the lesson, is be able to model and solve problems using absolute value. And again, absolute value is the distance that you travel, or the distance from zero. It could be in a positive direction, negative direction. We always report the absolute value as a positive distance or number. All right, that's all for today. Thanks for watching.